There is a piece of equipment used by British soldiers that costs less than 12 pounds. It is made from materials that were available in the 1940s. It contains no electronics, no batteries, no synthetic polymers, no advanced manufacturing processes. An American soldier looking at it for the first time would assume it belongs in a museum. And that piece of equipment has outperformed its American equivalent, which costs over $300 and represents the cutting edge of military textile engineering. In every single cold weather trial conducted by NATO in the last 15 years, every single one, not most of them, not in specific conditions, in every controlled comparison, in every climate, in every duration test, this piece of what Americans would call outdated British kit has proven superior to the technology designed to replace it. And the reason why tells you something profound, not just about military equipment, but about how two different cultures approach the fundamental question of what a soldier actually needs to survive and fight. Because the British military has a relationship with equipment that the American military does not understand, has never understood, and may never understand. And that relationship has been quietly saving British soldiers' lives for decades, while American procurement has been spending billions of dollars solving problems that did not need to be solved. All right, I need to start with something that will sound almost offensive to American ears. And I want you to hear me out before you react, because this is not anti-American sentiment. This is a doctrinal observation that American military professionals themselves have been making internally for years. The United States military has a technology addiction, not a technology advantage, an addiction. And like all addictions, it solves a short-term need while creating long-term dependency that ultimately undermines the very capability it was meant to enhance. The American defense procurement system is the largest and most sophisticated military-industrial complex in human history. It employs hundreds of thousands of engineers, scientists, and program managers. It spends over $800 billion annually. It produces weapons systems, communications networks, surveillance platforms, and individual soldier equipment that represent the absolute pinnacle of human technological achievement. And at the individual soldier level, where a human being must carry their equipment on their back and depend on it to keep them alive. This system produces gear that is frequently inferior to equipment the British designed decades ago and have never seen a reason to replace. That is a provocative statement. Let me prove it to you. I am going to do it not with one example, but with a systematic comparison across multiple equipment categories. Because the pattern is what matters here, not any individual item. The pattern reveals a philosophical difference so fundamental that it explains not just equipment choices, but training outcomes, tactical decisions, and ultimately operational effectiveness in the harshest conditions on Earth. Let me start with the item I mentioned at the beginning. The British Army wool shirt. It is officially designated as the Shirt Norwegian Army, though soldiers universally call it the Norwegian shirt, or simply the Norgie. It is a heavyweight wool pullover with a zip neck, loose fit, and no features whatsoever that would qualify as modern by any textile engineering standard. It is itchy, is heavy when measured by the gram per unit of warmth metrics that modern equipment designers use. It is slow to dry when soaked completely through. By every quantitative measure used in modern military procurement evaluation, it is inferior to the synthetic and blended alternatives that have replaced wool in virtually every other NATO army. And it is the single most effective cold weather garment in NATO service. This is not opinion. This is the conclusion of repeated comparative testing conducted under NATO cold weather operations working group protocols. Let me tell you why. Because the reason illuminates everything I am going to show you today. Modern synthetic insulation works by trapping air in a matrix of fine fibers. This trapped air prevents convective heat loss and maintains a warm microclimate around the body. In laboratory conditions, synthetic insulation is lighter, more compressible, and provides more warmth per gram than wool. These are the metrics that procurement evaluations measure, and by these metrics, synthetics win decisively. But soldiers do not operate in laboratories. Soldiers operate in conditions that destroy the properties synthetic insulation depends on. When synthetic insulation gets wet, either from external moisture or from perspiration, the fine fiber matrix collapses. The trapped air escapes. The insulation value drops catastrophically in some materials by as much as 70%. When this happens at -30 degrees, the consequences are not uncomfortable. they are potentially fatal. Modern moisture-wicking systems are designed to address this by moving perspiration away from the skin and through the insulation layers to the outer shell where it can evaporate. This works brilliantly in moderate cold. In extreme cold, the moisture migrates outward and then freezes within the insulation layers because the outer shell temperature is below freezing. The insulation becomes progressively loaded with ice crystals over extended operations. After 48 to 72 hours of continuous use in extreme cold, a synthetic insulation system can contain enough frozen moisture to reduce its insulating value by half. The soldier wearing it is slowly freezing inside their own equipment and may not realize it until the symptoms of hypothermia are already advanced. Wool does not behave this way. Wool fibers are naturally crimped, creating air pockets that are structurally maintained even when the fiber is wet. Wool can absorb up to 30% of its own weight and moisture before the wearer feels damp, continues to insulate when wet because the fiber structure does not collapse. It generates a small amount of heat through an exothermic reaction when it absorbs moisture. And it resists the accumulation of odor-causing bacteria, which is operationally relevant when you are wearing the same garment for days or weeks without the opportunity to wash it. The British Army knows all of this not because they conducted a study. They know it because they have been operating in Arctic conditions continuously since 1951, when they established their permanent cold weather training commitment to NATO's northern flank. 70 years of soldiers wearing wool in the worst conditions on Earth has produced an institutional knowledge base that no amount of laboratory testing can replicate. The Norge works. It has always worked. And no amount of technological innovation has produced a synthetic alternative that works better in the conditions where it matters most. The American military replaced wool with synthetics across its cold weather clothing system beginning in the 1990s. The Extended Cold Weather Clothing System, ECWCS, is now in its fourth generation. Each generation has been lighter, more compressible, and more impressive in laboratory testing than the last. Each generation has cost significantly more per unit, and each generation has produced soldiers who are colder and extended Arctic operations than a British soldier wearing a wool shirt that costs less than a pizza dinner. I am not exaggerating this. American soldiers who have participated in NATO cold weather exercises alongside British forces have reported this discrepancy consistently for over 2 decades. The reports are in the after-action reviews. The complaints are in the feedback channels. The data is in the comparative testing. And the American procurement system continues to develop synthetic alternatives because the procurement system evaluates equipment using metrics that favor synthetic performance and does not adequately weight the real-world conditions that favor wool. This is not corruption. This is not stupidity. This is a system doing exactly what it is designed to do, optimizing for measurable performance parameters and producing outcomes that fail in conditions the parameters do not capture. No. Let me show you that this pattern extends far beyond a single shirt. Because if this were just about wool versus synthetics, it would be a footnote. It is not a footnote. It is a systemic philosophy that touches every piece of equipment a British soldier carries. British military boots are another example that drives American soldiers and equipment reviewers to frustration. The standard British combat boot has been criticized for decades as heavy. It's uncomfortable and technologically primitive compared to American alternatives. American combat boots feature lightweight synthetic uppers, advanced cushioning systems, moisture-wicking liners, and ergonomic designs developed using computer modeling and biomechanical research. They are comfortable. They are light. They are a pleasure to wear on a 10-kilometer road march on a paved surface in moderate weather. In the field, over extended operations, in mud, water, rocky terrain, and extreme temperatures, British boots consistently outperform them. And the reason is the same fundamental principle that explains the wool shirt. British boots are designed for the worst conditions, sustained over the longest duration. American boots are designed to perform well across the broadest range of conditions for the shortest expected duration. British boot design prioritizes 3 things above all else: waterproofing that functions for weeks, not hours; sole rigidity that supports heavy loads over broken terrain without the foot fatigue that softer soles produce over time; and repairability in the field using basic tools and materials. A British soldier can resole their boots in a field workshop. They can re-waterproof them with standard issue dubbing. They can dry them by a fire without the synthetic components warping or delaminating. The boot is designed to be maintained by the soldier who wears it, using skills and materials available in an austere environment. An American combat boot that develops a sole separation in the field is a logistical problem requiring replacement from the supply chain. A British boot that develops the same issue is a 30-minute repair at the section level. This philosophy of soldier maintainability versus supply chain dependency runs through British equipment design like a structural beam, and it reflects a strategic reality that the British military has internalized and the American military has not. Britain cannot sustain the logistics footprint that American operations assume. Britain does not have the strategic airlift capacity, the global basing network, or the defense budget to guarantee resupply in all conditions. British planning assumes that soldiers may be cut off from supply chains for extended periods. It assumes that equipment must function without replacement parts, without technical support, and without the logistical infrastructure that American doctrine treats as a given. This is not a limitation the British are embarrassed about. It is a design constraint they have embraced, and it produces equipment that is fundamentally more resilient in the conditions where equipment resilience matters most, which is precisely the conditions where supply chains fail. Let me give you another example that illustrates this principle in a domain that might surprise you. British military cooking equipment. The standard British Army ration heating system is a solid fuel hexamine stove that weighs less than 100 grams and has no moving parts. You unfold a small metal frame, place a hexamine fuel tablet underneath, light it with a match, and heat your ration tin or boiling vessel directly on top. It works in any weather. It works at any altitude. It works when it is wet, frozen, or covered in mud. It has been in service in essentially the same form since World War II because it has never failed to perform its function, and nothing has been developed that performs the function better. The American equivalent has evolved through multiple generations of increasingly complex systems. Chemical, flameless ration heaters, compact multi-fuel stoves, integrated cooking systems with wind screens, pot supports, and fuel efficiency optimizations. Each generation is more capable, more versatile, and more impressive as a piece of engineering. Each generation is also more fragile, more dependent on specific fuel types, and more likely to malfunction in the conditions where a hot meal matters most, which is when it is bitterly cold and everything is wet and your fingers do not work properly, and you need calories and warmth more than you need a cooking system that performs optimally in a product demonstration. The British soldier boiling water on a hexamine stove in a snowstorm is not using inferior equipment. He is using equipment that has been ruthlessly optimized for the one thing that matters in that moment: reliability under the worst conditions with the least complexity. And this optimization philosophy, this willingness to sacrifice features and capabilities in exchange for absolute reliability, is the thread that connects every piece of British kit that outperforms its more expensive American counterpart. I want to take you into a different equipment category now, because the pattern becomes even more striking when you look at navigation equipment. The British military issues every soldier a Silva compass and trains them to navigate with map and compass as a primary skill. GPS is available and used, but it is doctrinally secondary. Compass is primary. Always. This seems archaic to American soldiers, who have grown up in a military that has progressively shifted to GPS primary navigation over the past 20 years. American land navigation training still exists, but its emphasis relative to electronic navigation has diminished consistently. The practical result of this difference became evident during a NATO exercise in the Baltic states where electronic warfare conditions degraded GPS accuracy across the exercise area. American units that had trained with GPS as their primary navigation tool experienced significant navigational displacement. Their soldiers could use a compass, but they could not use it with the fluency required to navigate complex terrain at night under operational pressure. The skill had been taught but not maintained because the technology had made it feel unnecessary. British units navigated through the same electronic warfare environment with minimal disruption because their soldiers navigate by compass every single week of their careers. The compass is not a backup system for British soldiers. It is the system. GPS is a convenience that supplements it when available. When GPS fails, nothing changes for the British navigator because nothing they depend on has been taken away. When GPS fails for the American navigator, their primary system has been removed, and they must fall back on a secondary skill that has not been practiced with sufficient frequency to be reliable under pressure. This is the dependency trap that technology creates, and the British military has been more successful at avoiding it than any other NATO force. It's not because the British are opposed to technology. They are not. British Special Forces use some of the most advanced technology available anywhere. British signals intelligence capabilities are world-class. British electronic warfare systems are sophisticated and effective. The difference is that the British military treats technology as a supplement to human capability rather than a replacement for it. Technology enhances what a soldier can already do, doesn't replace what a soldier must be able to do. This distinction sounds subtle, but it creates fundamentally different soldiers when you apply it across an entire military career. Let's address the most controversial equipment comparison between the US and UK militaries. It's the one that generates the most heated debate online: body armor. The British Osprey and its successor Virtues have been criticized for being heavier and less comfortable than their American counterparts. American body armor has evolved rapidly, using advanced ceramic plates, lightweight carriers, and modular systems that let soldiers adjust their protection level. The American approach is all about maximum protection for minimum weight, using the most advanced materials available. By comparison, the British approach seems less sophisticated. The armor is heavier, and critics say it restricts movement more. But there's a dimension to this that people consistently miss, and it connects directly back to that core philosophy. British body armor is designed to be manufactured using production methods and materials that can be scaled up rapidly in a major war. It avoids depending on specialized supply chains that could easily be disrupted. Think about it. Advanced ceramic plates in American armor need special factories, rare materials, and complex quality control. If that factory is damaged or the supply chain is cut, replacement plates become unavailable. British armor, on the other hand, deliberately uses materials and manufacturing processes that can be scaled using general industrial capacity that would likely survive a major conflict. This isn't about saving money. It's a strategic choice, born from the assumption that in a big war, peacetime supply chains will fail, and you still have to be able to produce your equipment. This focus on wartime production influences British equipment design across the board, and it's almost entirely absent from American thinking. American procurement is designed for peacetime efficiency. It assumes that you can just ramp up production in existing facilities during a war. British procurement, shaped by the institutional memory of 2 world wars, where production capacity was a critical vulnerability, designs for the worst-case scenario. It prepares for a situation where specialized facilities are destroyed and production has to be scattered across general industry. This is the difference between a military that has faced an existential threat to its homeland and one that has not. It's not a criticism of either side, but a recognition that real-world strategic experience shapes equipment philosophy in profound ways. But let's take this analysis somewhere most comparison videos never go, because the real significance isn't about any single piece of gear. It's about what this philosophy produces in the soldier. A British soldier, trained with simple, reliable, and maintainable equipment, develops a completely different relationship with their gear than an American soldier who uses complex, tech-heavy, supply-independent equipment. The British soldier understands their kit completely. They can maintain it, repair it, modify it, and improvise with it. Because it's simple enough to be fully understood by the person using it. They don't depend on a technician to keep their gear working. They don't need specialized replacement parts flown in from halfway across the world. They do want to feel that helplessness that comes when a complex system fails and the user has no idea why or how to fix it. This relationship with equipment builds a quality that the British military values above almost any other: self-reliance. The ability to keep operating when support is unavailable, when supply lines are cut, when the entire infrastructure of modern warfare has been disrupted or destroyed. In the British military, self-reliance isn't just a character trait. It's a strategic capability. Why? Because an army whose soldiers can function independently of complex support systems is an army that can sustain operations in conditions that would paralyze a force dependent on those systems. And in a major war against a peer adversary, those conditions aren't hypothetical. They are the most likely reality. Supply chains will be hit. Communications will be degraded. Logistics will be a constant battle. The force that can continue fighting when its high-tech systems fail is the force that will still be in the fight when the other side has ground to a halt. This is why British equipment choices that might look outdated or clunky to an outside observer are actually incredibly forward-thinking in the most fundamental strategic sense. They are designed not for the last war, but for the one that might be coming. Thanks for watching. If you found this perspective interesting, be sure to like the video and subscribe for more deep dives into military strategy and philosophy. See you in the next one. The war that has been the counterinsurgency campaigns of the past 2 decades favored high-technology individual equipment because the logistics infrastructure secure, the supply chains were functioning, and the operating environment, while dangerous, did not threaten the systems that supported the soldier. The war that is coming, a potential conflict with a peer adversary capable of striking logistics nodes, disrupting communications, and contesting every domain simultaneously, will favor equipment that functions independently of those systems, that insulates when wet without batteries, compasses that navigate without satellites, boots that can be repaired without supply chains, stoves that work without specialized fuel, body armor that can be manufactured without specialized facilities. The British military is not clinging to outdated equipment because it cannot afford better technology. It is maintaining proven equipment because it has made a strategic calculation that simplicity and reliability are more valuable than sophistication and capability in the operating environment it expects to face. And this calculation is informed by something that the American military, for all its extraordinary strengths, does not possess. The institutional memory of fighting a total war where the homeland was under direct attack, where factories were bombed, where supply ships were sunk, and where soldiers had to fight with whatever they had because replacements were not available. Britain experienced this within living institutional memory. The officers who built the post-war British military had personal experience of equipment failure at the systemic level. They knew what happened when the supply chain collapsed. And they built an equipment philosophy designed to ensure that their soldiers could keep fighting when it happened again. I want to be very clear about something as I bring this analysis together, because balance matters, and I refuse to construct a narrative that serves one conclusion at the expense of truth. American military equipment is not inferior to British equipment in any general sense. In most operational contexts, American equipment is superior. The American individual soldier system provides better protection, better situational awareness, better communications, and better lethality than the British equivalent. American infantry squad equipped with its full complement of technology is more combat effective than a British section in the majority of tactical scenarios. American night vision is better. American communications are better. American weapon optics are better. American body armor provides better protection per kilogram. These are facts, and I am not going to pretend otherwise to make a cleaner narrative. But capability in optimal conditions is not the same as resilience in degraded conditions. And the question that every military planner should be asking is not which equipment performs best when everything works, but which equipment still performs when nothing works. When the batteries are dead and the satellites are jammed and the supply convoy was destroyed, and the repair facility was hit and the weather is -30, and you have been operating continuously for 72 hours. What equipment do you want to be wearing? The American answer to that question has historically been to ensure that the batteries are never dead, the satellites are never jammed, and the supply convoy always gets through. And the extraordinary resources of the American military have made this approach viable for decades. But viability against insurgencies and regional powers is not viability against peer adversaries. Russia can jam satellites. China can interdict supply chains. Both can strike logistics infrastructure at strategic depth. And in that environment, the soldier wearing wool, navigating by compass, eating rations on a hexamine stove, and wearing boots he can repair himself, is not using outdated equipment. He is using equipment designed for exactly the war he is about to fight. The 12-pound Norgee is not a relic. It is a prophecy. A prediction that the future of warfare will belong to the force that can sustain itself when the systems fail. The British soldier pulling it over his head on a freezing morning. The same way British soldiers have been doing for 70 years is not behind the times. He is ahead of them. He just does not know it yet. And the American soldier shivering in his $400 synthetic system, Wondering why his battery-powered heating element stopped working at -25 is learning the same lesson that every military eventually learns. Technology is a tool, reliability is a weapon. And in the harshest conditions on Earth, the weapon always beats the tool. So what do you want to explore next? I'm working on an analysis of why the French Foreign Legion still issues equipment that most NATO armies abandoned decades ago, and how that equipment philosophy produces soldiers who adapt to austere environments faster than any other Western force. Or perhaps you want to see the fascinating reason why Israeli combat units have developed a completely different approach to soldier load management that contradicts both American and British doctrine and produces measurably better results in their specific operational context. Tell me in the comments if this analysis changed how you think about what makes military equipment truly effective. Subscribe now, because next week I am releasing a video about a piece of British Special Forces equipment so simple that American operators initially refused to use it. Within 6 months, they were requesting it by name. You are going to want to see that one.